Welcome. In this tutorial video we'll be looking at an inverse matrix. Particularly it will be the TI-Nspire CAS calculator. We'll examine how to calculate the determinant of a matrix and then as a result of that how to calculate the inverse matrix. So let's have a look. The inverse matrix is given the symbol of the letter for the matrix, in this case A, raised to the power of -1. And if we're trying to calculate an inverse matrix, we need first of all to calculate the determinant of the matrix. There's several different ways determinant can be written. There's just the traditional determinant of matrix A. Using the calculator, they use a function det for determinant A. They also use the modulus symbol, the two straight lines with the A in between. So here's an example. We've got the matrix 2, 3, 1, 4 reading across the rows, and I want to find what is the determinant. Now the determinant ends up being a number, either positive or negative, which is associated with that particular matrix. So step one, a manual way to find the determinant of a known matrix, is to calculate the product of the main diagonal. Now by the main diagonal I mean the numbers here 2, 4. The diagonal of this 2 by 2 matrix going from top left to bottom right. So the product of the 2 and the 4 is 8. Step 1. Step 2 is to find the product of the opposite diagonal of the matrix. Now what we mean by the opposite diagonal, instead of top left to bottom right, we mean top right to bottom left. So the product is 3 by 1, gives me a value of 3. And finally, to calculate the actual determinant, we have to take away the product of the opposite diagonal from the product of the main diagonal. So from the 8, in red we have here, we take away the 3. The determinant for this matrix, matrix A, is 5. That can very quickly be done using a 2 by 2 manually, just looking at the products of the two diagonals. However, if you're doing a larger matrix, 3 by 3 or a 4 by 4, calculating the determinant is a lot quicker by using your CAS calculator. So let's examine this scenario. So a determinant is a predefined mathematical function, so I can look at the list and look for det for determinant. Oops, let's D as we go down, and we will eventually find determinant. However, I find it just as easy to type in det. It recognizes it straight away. And then we put brackets, which is important, and then just enter in our matrix. So this matrix again was 2, 3, 1, 4. Press enter and our answer is 5. There we go. The determinant of that matrix is 5. Very quick. Look, that can be done, for example, if we had a massive matrix, which you wouldn't traditionally do manually. Let's make it a 4 by 4 matrix and randomly throw in some numbers. Every square matrix has the determinants. -2, 5, 7, -4 and 2. 378 for that particular matrix. The calculator is a quick way to go. Very good. Okay, so if we want to find the inverse of this particular matrix, we have several steps. The first one is to calculate the determinant, which we just did. Step 1, multiply 2 by 4 and subtract from that the product of 3 by 1. Comes out to 5. Step 2, we need to swap the elements of the main diagonal. Now we know the main diagonal, so the 2 and the 4 get swapped over as a 4 and a 2. Step 3 is we multiply the elements of the opposite diagonal, again the 3 and the 1, by -1, effectively changing the sign. So that becomes a -3 and a -1. And then finally, with that particular step 3 matrix, we now multiply 1 over the determinant from the previous step 1. So 1 over the determinant was 1 over 5. So here's our switched main diagonal, our reverse of the sign on the opposite diagonal, and we're timesing it by 1 over the determinant of 5. So it can be written with the determinant fraction out the front, Or you can multiply that through each individual element, because 1/5 of 4 is 4 on 5. 1/5 of -3 or -3 is -3 on 5. 1/5 of -1 is -1 on 5, and 1/5 of 2 is 2 on 5. Very simple. As always, you can do this with your calculator just as easily as well. So let's have a look at that particular action. We'll start a new screen just to clear it. Start again. In this example, I'll have a look at using define function instead of having to type it out. So I want to define matrix A to be equal to, the values for A were 2, 3, and 1, and 4. And it's done. So if I type in the letter A and press enter, it gives me that matrix. So let's have a look. That matrix raised to the power of -1 is what we mean by the inverse. Hit it, and there's our values. 4 over 5, -3 over 5, -1 over 5, and 2 over 5. Now that should be exactly the same as what we got there. So to do an inverse matrix using a calculator is a lot quicker. However, as always with multi-choice exam questions, it's good to understand the manual technique in terms of swapping the main diagonal, changing the signs of the opposite diagonal, and multiplying by 1 over the determinant. Finally, we can always check to see if our inverse matrix is correct, because when you multiply a matrix by its inverse, the product should be the identity matrix. So let's just try this one. We could take A, the predefined matrix, and multiply it by A to the power of -1, which is its inverse, and that gives you an identity matrix, which is great. Alternatively, again, we could have said, let's start with a 2x2 matrix, 2, 3, 1, a 4, the same procedure, just using a different calculator function, control and var. We can say, let's store that to A, which is done, and now say A multiplied by, again, the inverse of A. Or for those who want to do the slow and more meticulous way, we could enter it in as 2, 3, 1, and 4, and multiply that by its inverse. Okay, and this time using our fractions. So the first value was 4 over 5. The second value was -3 over 5, or -3 on 5. The next value was -1 on 5. And the final value was 2 on 5. And again, the product of the matrix and its inverse is the identity matrix, so this has been performed correctly. Stay tuned. In future videos, we'll examine how we use the inverse matrix to solve simultaneous equations and other applications. Thanks for viewing.